For this video, we're going to be looking at some of the more challenging things that we've been working on throughout this unit, and we're just going to be reviewing some of these main topics. So the first thing is one of the things we've been focusing on, and that is the different forms of writing a quadratic equation. So there are three ways we can write a quadratic equation. The first is standard form. And standard form is useful because we can see the a value here. So that helps us to know if it's going to be facing upward, facing downward. We also have our little c value over here, and that is our y-intercept. So that is useful. Now, standard form is important because this is the one you will honestly see the most. It's the most simplified one. It's the one that people think look the nicest and most concise. So typically this is the one you will see written out. So you'll have to convert it if you really want to do anything with it. Second is vertex form, and we are focusing a lot on vertex form in our other units. And this one is great because we can see our vertex with our h and our k. So that's very useful. And then again, we can still see our A value here, which is lovely. And again, that will tell us if it's been stretched, compressed. So vertex form is awesome because we can see all of our transformations. And if I'm looking for a minimum or a maximum, I can also find that. So loads of benefits to why we would use vertex form. And finally, we have factored form. And that one is new for this unit. And this one is great because we can see the zeros. And our zeros are right here with our R and our S. And it's really beneficial, especially when we're trying to solve for things and we're trying to find the value of our X's. So what we're going to do now is we're going to look at how we can convert from one form to the next. So we've saw this kind of chart before, but I just want to reiterate it. So to go from standard form, our most basic form, to vertex form, we would just complete the square. So we haven't done that in a while. So I'll go through and I'll do an example below. But that's what we were doing last unit when we were trying to find our maximums and our minimums. If I wanted to go from vertex form to standard form, I could just multiply out the brackets, collect like terms, and that is referred to as expanding and simplifying. Next, if I'm going from standard form to factored form, I simply just factor it. So we'll do an example of that as well. And then if I'm going from factored form to standard form, I can just multiply out those brackets and collect like terms again. Now, the other thing we have been doing, and I think that this is a piece where some disconnect is coming from, is we have been going directly from factored to vertex form. And we do that by finding the x of our vertex and the y of our vertex. So we will also do an example of that as well. So for our first example, we have this equation here, and that's going to be the equation we're going to focus on for all of these examples. So for part A, we're being asked to convert this equation to factored form. So if I'm not sure how to do that at this stage, I'm just going to look up here, and I'm going from standard form to factored form, so I'm just going to factor it. Eventually, you'll get to a point where you don't need to reference the chart, but if you do have to for right now, that's totally okay. So I'm just going to write it out. And now we're going to factor this. So the first thing we always do is look for any numbers I can common factor. So each of these are actually all divisible by 3. And then because that first number has a negative on it, I always want to pull out that negative as well. So let's factor out that negative 3. And we're left with x squared minus 2x minus 35. There we go. And now we need to find our two numbers that add to our middle number, which is negative 2, and our two numbers that multiply to our a times c, which is negative 35. If you're still finding that factoring is something you're struggling with, definitely worth reaching out, asking for help, and also checking out our Unit 4 notes. So if I go to fill in these blanks, we'll get negative 7 and 5, negative 7 and 5. And because in the brackets, the value on the x squared is just 1, I can jump right to my brackets. And we'll be doing some more factoring below, so if you need more examples, they will be coming later. So that is our equation in factored form. So once I have it all in the brackets, that's factored form, and I'm good to go. Now, when we get factored form, the useful part about factored form is I can find my zeros. So below here, it is asking for my zeros, and they will be beneficial in trying to find my vertex. So let's go through and find our zeros. And to find my zeros, I just set the equation equal to 0, like this. And now I'm going to be solving for x. So that -3 is being multiplied by the whole thing. So in order to get rid of that, I'm just going to divide it out on this side, divide it out on this side. 0 divided by -3 is just 0. So that goes away, which is lovely. And now I can just set those two brackets equal to 0. So we have x minus 7 equals 0. So that will give us x equals +7. And we get x plus 5 equals 0. So that gives us x equals -5. So now, in addition to having our factored form, we've also used it and showed how useful it is. And we found our zeros at 7, 0, and at -5, 0. Okay, so that's the first one. And I think that that is one part that people aren't having too much trouble with. I think it's the vertex part that is getting a little confusing. So for the second one, we're going to convert this equation to vertex form from our factored form. So we're going to be starting with our factored form here that we just found in the last step. And we're trying to get it to vertex form. So the information we have so far is we have our factored form and we have our zeros. Now, because a parabola is symmetric, it means that our vertex is going to happen right in between our zeros. So if my parabola looks something like this, 7, -5, something along these lines, then our vertex, the x of our vertex, should be right in between -5 and 7. So to find that spot that's right in between, it's very similar to when we were doing midpoint. So I'm just going to add those two together and then divide it by 2. So I'll get 2 divided by 2 equals 1. So what we know so far is that our vertex is 1 something. So we need to find our matching y. And to do that, we just sub that x value into our equation. And it does not matter if you want to use the standard form equation or the factored. They represent the exact same relation, so it doesn't matter which one you plug it into. I'm going to plug it into the factored one because I find that it's a little quicker. But if you want to do the other one, even just to prove to yourself it works, that's absolutely not a problem. Go. And then we'll get 3 times 6 times 6 equals 108. There we go. So our vertex is 1, 108. So now, because we have our vertex, we can write this whole thing in vertex form. So remember, my vertex form is y equals a x minus h all squared plus k. So I have my y equals the a value I'm just going to get from my standard form over here, so -3. H is the x part of the vertex with the sign swapped. And then we just have k, which is the y part of our vertex. So that is our equation in vertex form. All right, last one. This is actually a question from last unit, but I think it fits in really nicely here and ties everything together, is to go from standard form to vertex. So to complete the square. The nice thing about this is you'll be able to see how completing the square should give us the same vertex form that we just found. So our standard form was y equals negative 3x squared plus 6x plus 105. So our first step is we put brackets around those first two terms and we factor out that first coefficient. And then we need to find that magic number. So to do that, we take this value here and we divide it by 2 and then we square it. So in this case, we're going to get negative 2 divided by 2 is negative 1. All squared is 1. And then we just add and subtract that in the bracket. All right, and then we take the negative 1 and it's got to go out of the bracket. But we have to be careful because we need to multiply it by that negative 3 that we factored out in the beginning. And when that comes out, we get plus 3 plus 105. And now I can factor that bracket. So I'll have x minus 1 all squared. It is a difference of squares. Sorry, a perfect square trinomial. But if you need to do it the long way, that's absolutely okay. And then I have plus 108. So I end up with the exact same equation and the exact same vertex. If you're struggling with completing the square, I would highly recommend going back and watching that video again or letting me know if you have questions. Okay, so there's one to try below. I would highly recommend just pausing the video here, giving it a try and checking your answer right now instead of waiting till the end. So the answer to that will be posted on Google Classroom. Now, the second thing that I wanted to quickly review and just discuss again was solving quadratic equations. So we've solved loads of equations, right? And especially we were doing it with different variables early on in the year, and we've done a ton of stuff using opposite operations. Now things get just a little more complex when we have these x squareds floating around. And we often will have two answers, so we just need to be really mindful that we're getting all of the answers. So when we're solving, these are always going to be your steps when you're solving a quadratic. First, make sure your equation is equal to 0. If it is not, you need to rearrange it and fix that. This only works if it's equal to 0. Next, we're going to try to factor the equation. If you can factor it, you're going to go to the steps on the left. If you cannot factor it, you're going to go to the steps on the right. Let's say you tried to factor and you couldn't figure it out, and you ended up using the quadratic formula. That is absolutely okay. It's not as efficient, but you'll still end up with the same answer, so it's all good. So let's try these three examples. So the first one here, we have negative 25 equals 2x squared minus 17x plus 10. So the first thing we need to do is make sure it's equal to 0. Again, does not work if it's not equal to 0. So let's move that 25 over. Next, we're just going to make sure it's in the right order and that we collect any like terms. So our order is fine, but we do need to collect those like terms there. So now we have it simplified, equal to 0. We are ready to start on our next step. So the next thing we want to do is we want to try to factor this thing. So I'm going to look at it, first see if I can common factor anything out. Nope. And now I'm going to try to factor it. So I need two numbers that add to my middle number, which is negative 17, and two numbers that multiply to a times c, which in this case is 35 times 2, which is 70. And those numbers will be -7 and -10, -7 and -10. So because I'm able to find these numbers, it means that I can factor this. So this is the way that I should solve it. So I'm solving with the steps on the left of that dotted line. So let's, instead of writing a -17, we know that -7 and -10 work for that. So -7x, -10x. Next, we factor as much as we can out of our two groups. So the first one, all I can factor out of there is an x. So I'll be left with 2x minus 7. And for the second one, I can take out a -5. So I'm left with 2x minus 7. Now we have a nice checkpoint here. We got matching brackets, so that's a good sign that we did everything correctly. And now we can take those matching brackets out, 2x minus 7 and x minus 5. Next, what we're going to do is we are going to set each of these brackets equal to 0. So we'll do that with the first one here. 2x minus 7 equals 0. And then this one, x minus 5 equals 0. And now we're just going to rearrange things. So for this one here, the -7 will go to the other side. And then I can divide out that 2. So our x is 7 over 2. And over here, move that 5 over, and we'll get x equals 5. So those are our two answers. So for the next one here, let's follow our steps again. First thing, we look to make sure it's equal to 0. So because it's equal to 0, we're good to go. Next, we're going to see if we can factor. So we look here and we're going to try to common factor out as much as we can. So we can common factor out a 12x. Oops, sorry about that. And we're left with x minus 2. And now we have our two brackets. So when I have something in the front here that has an x, that counts as a bracket. If it's just a number, it doesn't count as a bracket, but if it has the x along with it, it does. So now we can set those two brackets equal to 0, 12x equals 0, and x minus 2 equals 0. So to get x all by itself in our first one, we're going to divide by 12, so x is 0. And our second one, we just move that 2 over, so x is 2. And the nice thing about these is you can absolutely plug in those numbers and double check if it works out. Okay, let's try our last one. Sorry, that should not say y, it should say 0. It's corrected on your sheet. So first thing we do is we make sure it's equal to 0. So I fixed that, that was a typo, so sorry about that. So it's equal to 0, and now we see if we can factor it. So if you go through and try to factor this, it does not work. Majority of your test questions will say factor using quadratic formula or something like that. It will give you a clue as to whether or not it will factor. But in this case, I'll tell you right now it doesn't. So what we do is we identify our A, our B, and our C, and we're going to sub it all into our quadratic formula. So we'll have -3 plus or minus the square root of -3 squared minus 4 times 7 times -9 all over 2 times 7 plus 252 all over 14. And then because of that plus minus sign, this is actually two equations in one. Three plus the square root of 261 all over 14. And we'll have x equals 3 minus the square root of 261 all over 14. So our square root of 261 is 16.15.
So our first answer is going to give us 1.37. And if you rounded slightly different than me, you might find you have a little bit of rounding error, but that's okay. And 0.94. So those are really our options for solving. So there's a few below for you to try and to see how it goes.